This is my furnace, and today what we're going to do is replace this gas valve. The gas valve is responsible for letting the gas come in and through and up to the burners. So there's a sequence of events that has to occur before the gas valve opens. I'm going to talk about those a little later, but for now, trust me, I've already determined that this is the issue because all the other conditions have been met, and even to the point where if I tap on the gas valve and wiggle the wires, I can make it open. That's not 100% proof that it is the gas valve. It could be a loose wire or loose connection somewhere. But in my case, I've ruled all that out, and I know that the gas valve is a little iffy. So first thing is first, we're going to shut the gas off to the whole house. We don't want to blow up ourselves. But let me make a disclaimer. First of all, I'm not a licensed gas technician. My background is electronics. I'm an electronics technologist. So I'm able to follow all the electrical pretty easily. There's a board down here in this compartment which will show you error codes, and you can check voltages there and follow them throughout the different wiring harnesses and make sure that the voltage is getting to where it's supposed to be getting. And I have determined that at the proper time, the voltage here into the relay of the gas valve is present. It's nominal 24 volts, but it fluctuates a little bit. In this case, it's about 26 to 28 volts. So this video is for informational purposes only. It's not designed as a definitive guide to fixing your furnace. Leave that to the professionals. You could seriously harm yourself, damage property, and even lose your life if you make some crucial mistakes. So let's get started. I'm going to go outside, and I could turn off the gas here as well. There's a shut-off valve into the furnace from there as well. I'm going to shut that one off, and I'm going to shut off the one coming into the house for safety. So I'll be right back. The gas is off, and let's start. So I'm going to disconnect this wire here first. Make sure my camera is focused properly. Okay, so we're going to begin by removing this over here. It's called a union coupling, and the reason why you got to start there is because you can't unscrew anything. As soon as you start unscrewing one pipe, it tightens into the next fitting. So they have this thing called a union coupling, which allows you to disconnect the entire thing here, and then one by one remove pipe. So I'm going to get started. I'm going to give you a close-up how this union fitting works. So this screws up into here. You smell the gas coming out. Okay, so this screws into here. It's pretty tight. I'm just gonna, so that's the way it goes, and now you can unscrew it here. And this over here makes a seal. No tape, no sealant, nothing. It's just metal against metal, and that makes a really good seal. You're not supposed to use any kind of sealant or tape in this case. There are other cases where you do. So now we just begin to dismantle it piece by piece, and we'll take another wrench here. Vice grips, where are you, vice grips? There you go. Basically, I'm going to remove this pipe here now from this elbow. So you can see why there's this union connection here, because without that you're turning this pipe, and if this were all one piece, you're turning it this way and you're tightening it over there, so you're really not getting anywhere. So that's why there's this union fitting, which is crucial for putting these things together. So save that. Now we can remove this entire piece here. If we had room here, we could just untwirl it, but we don't have room for this big piece of pipe. So now we can just take this thing here and turn it and get it out pretty easily. And that'll pave the way for removing the internal pipe and going to the gas valve. Save this piece as well. We're going to clean all these fittings afterwards. So now you see this piece here is going into an elbow. We have to unscrew it before we can get this part out, because there's not enough room otherwise. So I'm put down this in here and take my vice grips. I remember where I put them. Here they are. Okay. Pretty tight. You gotta go really slow with this, because too much force too quickly could damage something, so just go slow. Okay, get the other pipe out. Now, just take off whatever tubes, and just remember where things go, so you can always put it back. But like I said earlier, this is not a how-to, this is just an informational video. So the reason why I'm making this video is to help somebody out, because I've watched other videos that helped me out with this, and now hopefully I'm helping somebody else out. Okay, so I've got a little bit of a dilemma here, because you see this is a switch over here. It's a pneumatic switch. So this motor here creates suction, and we're going to get into the sequence of events, but at one point this motor creates suction and it pulls a diaphragm and makes this switch closed. But we got to take this thing off before we can get this pipe out. And besides having the gas off, make sure you have the power off to the furnace before you do any of this. Not that you're going to do this, but you know what I mean. Okay, so now I can proceed to remove this pipe. And I got another snag because I can't go all the way around without removing that, but that's a lot of work. So at this point I'm going to take off this little nipple pipe over here, and that'll serve the same purpose. Unscrew this one, and I couldn't have done that before because this was too tight. So now tighten this up a bit so I can get another turn. So now, while holding the nipple, you pull this piece of pipe over so that you can get another maybe quarter turn out of that, and just repeat as often as necessary. And if you really have to, you could disassemble this. It's just going to be more work to put it back together afterwards, but I might have to do that. I think Godzilla put these things together. Put that aside. Now hopefully this will come right off. And it does. Okay. Now we get into the fun part, removing the actual valve. So we take our other wrench. That wrench keeps disappearing on me. What did I do with it? Oh, there it is. I'm going to take this. Now, when you're doing this one, make sure you support this pipe here, because this pipe is not as thick as the other pipes, and although you're not going to break it, you don't want to bend it either. Okay, that is tight. Let me think here. I have to support it heavily before I can get some leverage in there. Oh, yeah. Okay, so that's not coming off. So we're going to have to do this at some point anyway. So we're going to cut all these tie wraps and remove the whole pipe and then do it while it's out of the system. So remove all these tie wraps here. And there's 4 screws holding, this is called the manifold, the gas manifold. I'm going to remove the gas manifold along with the gas valve all at one piece. That way we can work on it offline, so to speak. Now the burners are going to drop once you do this. They're not going to fall off, but you just have to be conscious of that they're going to go down. The manifold is holding the burners. And well, you could have done the other piece that was attaching here as well offline. I didn't think of that in this case. I just took off the wrong screw here. This screw here belongs to that pneumatic switch, which I left on there, so I'm going to lose it. It's this one here that I want to remove. Okay. So now we just got to be careful there. So now we have our manifold off, and these little jets are what the gas comes out of. So when this gas valve opens, letting gas through, it sends gas through these little jets here, these little orifices, into the burners, and that's what creates our blue light, or our blue flame. So now I'm just going to take this down the floor and remove this part here. My God, is it on there tight? Oh, shit. Okay, plan B. Pretty hard to get this thing off, so what I'm going to do is I'm going to stick it in a vise. Walk with me. If you don't have a vise handy, you're just going to have to get somebody to stand on this thing while you're doing that. Here in the shop of Lou, we have everything that you'll need. If we don't have it, you don't need it. So now this thing is locked in the vise, and we're going to push down on this to loosen it. There we go. That was tight. No wonder I couldn't get it off earlier. There we go. and it's off. Like I said, you could use some bigger wrenches and some leverage to get this out if you don't have a vise. Let me plug this one back in. All right, so now our gas valve is coming off. Here's our culprit here. Smells the gas. Now before we put any of the fittings back, all the pipe has to be cleaned like this with a wire brush. Careful not to get any wire inside the pipe, because that could be a problem, so that it's nice and clean. Okay, so I'm going to show you the new gas valve. Here's the new gas valve. Looks a little differently. This is a one-stage gas valve as opposed to a two-stage. Now, I don't care. I don't want two stages anyways. 99.999% of the time this thing's operated in full blast or no blast. So I just wanted to come on when the call for heat, and go off when it's not calling for heat. Take off these two little dust caps. Forgive me there. So there's an arrow here that indicates gas flow. Extremely important. So this is the direction that the gas is going to flow. So you know it's going to flow into the manifold, into this manifold. So the outlet goes into the manifold like this. So we have to use a sealant here. It's called pipe dope. I'll show you what pipe dope is. This is Masters Pro Dope pipe thread sealant. So you just it's a paste basically, and it makes a airtight, gas tight, water tight, everything tight seal. When you're applying this, don't get too close to the edge of the thread, because some of that sealant could go inside the pipe, and that's not the end of the world, but it's not good either. So just go carefully around the pipe, leaving about 1/8 of an inch of the pipe without any sealant. Just like so. Close enough for horseshoes. Take the new valve and the output. Pay attention to the arrow. The gas is going in this direction, so we're going to take this and just thread it on there. And you see, when it's threading on there, the pipe dope really makes a good seal. So now we're going to tighten this up as good as we can. And it doesn't have to be like Godzilla did it, but it has to be nice and snug. Forgive me if you can't see some of this. Let me change the camera. I'm going to put this on the ground in a second to really crank it And I want to make it so that eventually, because I'm going to be threading more pipe onto this end here, and when I'm turning that one, it's going to cause the valve to turn. So I don't want to go full blast here. Just tight enough so that it gives me some room at the end to turn the other pipe and hopefully turn the entire gas valve one more revolution. If that makes any sense. So now I have to put in an elbow like this again, a fitting like this, because I have to go back, towards the inside of the furnace, and then out that way. So I'm going to use the fitting that I took off, but I got to clean it first. Just clean that as well as you can, because the better you clean it, the better connection you're going to get, and the more turns you're going to be able to get. Okay, that's good enough. Let's apply some pipe dope to this fitting as well. Okay. You don't have to smother it, just get enough on the threads so that when it does tighten, that thread will create an airtight connection. That sealant will create an airtight connection. So now, pay attention to, okay, don't get any pipe sealant on the orifices. This is going to be like this at the end of the day. So now I'm going to tighten this fitting as much as I can, and I want it to be pointing that way, straight across, because I'm going to be attaching another little fitting, namely this one over here, to that end, so that it's going to go across. And I might just do that now, and that way, so I'm going to clean this one too. These wire brushes are really handy. You can get them on Amazon for like peanuts. Actually, everything that I'm using here, all these parts, I purchased off Amazon, including the gas valve. The gas valve is about 120 bucks, roughly 115 bucks or so. If I went to a gas reseller, they'd charge me probably over 200. Okay, good enough. I'm going to put some sealant on there. We're getting there, people. And then the fun begins. There you go. So this is going to go across like this, and then down like that, and this thing should be turned facing this way afterwards, but one thing at a time. So let's tighten this as much as we can, and then I'll tighten this one here later. Okay, peoples, took a little bit of work, but I think I got it in a good position. So that's going to go back up here, and now gas is going to come in here, make sure we're still pointing in the right direction. Yes, we are. And here, into the burners. So now I'm going to put it back in there, and then put the final piece of pipe in here. And then we got to do some electrical work. Be careful not to damage anything. So now you're going to have to hold these burners in place long enough to get the screws in. I hope you can see that. You just get it roughly in the right position. So that the burners stay. Okay. Get a couple of screws in there. Okay, just 2 screws in for now. Just check the, this one's not in. So we gotta loosen this one. This one's okay, this one's okay, this one is too low, you see that? That burner has to be in line with the orifice, so that when the gas shoots out, it goes and gets ignited. There you go. But what I want to do, I'm going to put these wires below. They don't matter. These are not polarity sensitive. They're just sensors. So I'm just going to route these. Disconnect one sensor at a time. It'll be a little cleaner. Same with this one here. and this guy here. This guy's this particular blue wire is going to this rod in there. It's called the flame sensor. So once the flame comes on, this thing is responsible for telling the electronic board down there that the flame is on, indeed on. Like we can see it's on, but the furnace needs to know it's on. And the way it does that is through this sensor here. The sensor is right in line with the flames, and once it gets hot enough, it lets the circuitry know, okay, I got flames. So then the furnace will continue along its merry way. Because otherwise, how does it know that the flames actually got lit? Anyways, we're going to get into the whole handshaking, the whole protocol after this thing's all done. I'll explain to you. So now we're going to put this pneumatic switch back on. And that's, believe it or not, the whole process of how this thing starts and starts heating is actually very interesting, in my opinion, because I got it backwards. You Dumbo Lou. Okay, now this thing goes in there. So I'll give you an example of how this works. So I'm going to pull this hose off the inducer motor. Listen for a click here. So maybe it's hard to hear in the video, but if I suck on this, there's a diaphragm that pulls against a copper contact, if you will, and it makes a continuity between these wires here. So I told you guys not to forget where things go, and now I forgot where things go. Where did this one come from? Right over here. Okay. Next, we're going to hook up the gas pipe that goes in there, that eventually goes into the main input. And okay, so the gas is all hooked up now. You can see the union is on there. I still have to tighten the union, but it's on there, and all this is on there, and all that's there. It worked out pretty well. So now I'm gonna do the wiring, and put the wire nut on. There, and one more here. Done. So this I'm just going to leave hanging, because it's not going to connect to anything. I'll put some tie wraps on later. So at this stage in the game, we're ready to try it out. Just look over your connections, but I'm going to get I'm going to prepare some soapy water. This is for testing for leaks. With soapy water, we'll be able to see if there's any gas leaks. There'll be some bubbles. If there are no bubbles, then there's no troubles. See what I did there? No bubbles, no troubles. Okay, I forgot to tighten the union. I'm going to do that before I blow up the house real good. Take some of the soapy water and just sprinkle it on all the fittings. You're going to see some bubbles, but they should not grow. And if you destroy them, they're not growing. In fact, they're diminishing, which is good. And just do that to all the joints that you disturbed, even the ones that you didn't disturb. At this point the gas valve is off, so we're not going to get any gas here, but we can test before the gas valve. I'm pretty confident it's not going to leak because we put enough pipe rope, we tightened it up pretty good. So now I'm ready to fire it up. Turn on the switch here. Okay, so pay attention to this glow. There should be a glow coming out of there. Here's the glow. The next thing is the flame, if everything's working okay. Opens. Nice blue flames. So far it's working. Let me just keep an eye on it for a bit. And keep your nose open for alerts here. If you smell anything, that could be a gas leak. Natural gas is odorless, but the gas company mixes in some methane so that you can detect if there's a leak. So you've got 1, 2, 3 orifices. This is the manifold. In this case you have 3. There's gas shooting out of those little orifices that you can't see it from visibly. But once it gets over there, it's ignited. Now you've got the turbine, whatever you want to call it. So let's go over some sequence of events here. How does this thing work? So the first thing that you're going to do, that's going to happen rather, is the thermostat, once it's set to a high enough temperature, it's going to call for heat. The thermostat's going to send a signal down to the board here, and it's going to call for heat. This thing is the first thing that fires up. It's called the inducer motor. The inducer motor, it pulls exhaust from out of the heat exchanger, which is inside the furnace, and then shoots it out through these vent pipes here. This one here. So you see the inducer motor here takes any exhausts that are stuck in the exchanger, and then puts it out through this pipe. This pipe goes outside. So that runs for a few seconds. Once these two pressure switches here, one of these is responsible for detecting that there's enough vacuum being pulled from the inducer motor. In this case, it's this one here. You can see this hose here goes to this switch here. So if there's enough vacuum generated by the inducer motor, this switch closes, okay, which sets you up for the next stage. If there's a kink in the hose, or this motor doesn't come on, the furnace is going to air code out and stop, and you'll see a sequence of LED flashing for an air code to give you a clue. And if this didn't sense enough vacuum, you're going to probably start looking at your inducer motor. There's something wrong with it. It didn't come on, or something. The next thing, that glow plug is going to come on. That glow plug, that's for the igniter. The igniter, once there's gas flow, the igniter will ignite the gas, firing it up. But before that can happen, the gas valve has to have enough power, 24 volts, and then the flame sensor, which is that little rod that I pointed to earlier, that senses that there's flame. Then there's a bit of a delay before the blower motor, that's the big motor inside the bottom of the furnace, which pushes air to all the duct in the house. Here's another tip for you. You see how the flames are blue? But there is a little bit of orange in there, but for the most part it's nice and blue. If there's a lot of orange, that's a problem. It can mean a few things. The combustion is not good, or there's a crack in the heat exchanger. Anyways, what I was saying earlier is you see how the flames are nice and blue? There's a touch of orange, but that's normal. But if you see a lot of orange, there's an issue, and you should call somebody to come and examine your furnace. There could be something not combusting properly, or a crack in the heat exchanger, a number of things which I don't know. what else could cause that, but there's a reason why it's not so blue. This is a good blue. This is normal monitoring other furnaces, and just to experience, this is a good color blue. Now, for your information, there's two pipes. Typically, there's two pipes for your furnace if you have what's called a power vent, which is, you see these PVC pipes. One is the output and one is the input. So this one is responsible for bringing air into the furnace, and you can see it's the input because there's nothing connected to it. So it goes outside, fresh air comes in. This one here, hooked up to the inducer motor, and it's responsible for blowing fumes out. And typically you should see one that's, when you're looking at it from the outside, you should see one pipe that's higher than the other. The higher one is for exhaust. So the theory there is you want it to be higher than the intake, so that when the furnace is blowing air out, exhaust combusted fumes outwards, that they don't make it back inside through the intake. If you put it high enough, I think the quote is like 18 inches apart from the intake. If it's high enough, then the fumes will go upward and won't go back inside. So that would defeat the purpose if you put them too close to each other. So when you're looking at houses, you see two pipes and you see them right side by side. It's not ideal. It should be about at least a foot apart and or more. Well, that concludes today's furnace gas valve replacement video. I hope you learned something, and if nothing more, it allows you to talk more intelligently to a gas tech, furnace tech, so that they don't pull the wool over your eyes and tell you that you need something that you don't. Usually they're sticking their hand in your pocket. Throw a few buzzwords like two-stage and inducer motor and solenoid and stuff like that. Make you sound more intelligent, and the guy will probably just fix it without ripping you off. At least that's the plan. Thank you for watching, and until next time. One thing I forgot to, did make one mistake. This thing is supposed to be facing downwards. This piece of pipe is supposed to be downwards to catch any sediment, so that if any sediment comes down here, it ends up inside this little piece. Before I had it upwards. Furnace still worked, but should be done right. That's the way they're supposed to be, facing downwards.